Howdy, I'm Izayah Allen, and today I'll be talking about predicting individual differences for learner modeling in intelligent tutors from previous learner activities. So the purpose of this research is to better individualize learning for students, specifically learning that involves more non-traditional methods such as online modules or types of curriculum that can be done individually without the typical teacher. So the idea is to try to better account for individual differences in students, such as the way they retain knowledge or how they read. So typical curriculum are derived from Bayesian knowledge tracking. This is the typical way in which they predict learner performance using certain metrics such as previous knowledge or difficulty with similar level material and things like that. And this kind of tracking is used to help with cognitive mastery. So they design curriculum and lessons around the idea that if there's a certain way that a lot of students perform well, they will craft the curriculum around that group of students. However, it only uses the knowledge that the student knows to calculate the IDWs. IDWs stand for individual difference weight. This is how they get the big, uh, the big picture curriculum. Each student has different things that they're good at and things that they're bad at. These things are essentially the individual difference weight. This number is averaged among a large amount of students. So for instance, if a large amount of students have really low reading comprehension, then the curriculum will be tailored to be more easily digestible, or maybe even less ready and maybe more visual or more audio based. So the procedure of the experiment, it involved a group of undergraduate students who were taking an Intro to Genetics class. These students, the goal was for them to complete two interactive modules. These modules were genetics-based modules, which have questions, text, graphs, pictures, but also interactive charts and imagery that they were able to use to complete the assessment. So first, the students were given instructions about how to use the module, and then they were given a conceptual knowledge pretest, which asks genetic-based questions that they may or may not have already known. And then the students were prompted to actually complete the modules. So while doing this tests, several things were collected, particularly these things called individualized predictors. This includes reading time, the time that they spent on any particular task, the error rate or the rate of questions which they got wrong, the average response time, and the pretest accuracy, or how accurate their answers were while they took the pretest. And each of these things sort of pointed at different things about how the student learned. So for instance, if their reading time was relatively high, then one might assume that the student isn't such a strong reader. And the idea of this is to say, if the student isn't such a strong reader, we could craft the module to better accommodate them, either through more visual or more audio outputs. Or similarly to in a different sort of way, the pretest accuracy also sort of showed that if the student already had high knowledge of the information before they actually use the module might either shorten itself so that the student doesn't have to go through information that they already know, or it goes more into depth so that the student can still learn, but they're not learning the same thing over and over. And so the conclusion was that there are certain predictors that could successfully be used to choose the best way to teach students based on the individual weight differences. In particular, the previous the predictors dealing with previous knowledge showed some of the strongest correlation with tailoring curriculum after. However, it was also shown that there were a large amount of predictors that were not actually very useful in determining a better way to teach students. And so the overall conclusion is that there are a few strong predictors that should be used, such as prior knowledge and any major outliers, such as if a student took an incredibly amount of time to read a passage or something similar, and then use these to try to better individually tailor a curriculum or a module for a student's learning.